All right, so I am going to go over the inequalities test review. Okay, so question number 1, which is an algebraic inequality that translates 8 less than a number is at least 10? So the first thing I would do is I would circle that is at least 10. That's going to be my inequality symbol. And then I'm going to box the than and underline everything after than, because that's going to tell me the order in which I translate. So this part comes first, a number. So you can choose any variable, such as x. 8 less, that's going to come second. 8 less means minus 8. And then is at least 10, that's going to be greater than or equal to 10. So if I look at my options here, they used n, that doesn't matter. And so the correct answer is this last option. So if you look at the options, the order does matter. Some people might think it's the second option, but because there's a than, you have to go back to front. All right, number 2, solve. So I'm going to rewrite it over here. And I notice that the coefficient is negative, so I'm going to go ahead and flip it. And then I'm going to drop my bar. Again, the reason why I flipped the inequality symbol is because the coefficient of b is -6, so it's negative. And then I'm going to remember my inverse operation. So my goal is to get b by itself. So I'm going to get rid of the constant first by subtracting 2 on each side. I'm going to bring down the -6b term. I'm going to bring down the inequality symbol, which is less than or equal to. And then -34 minus 2 is -36. Now my last step to get b by itself is to divide each side by -6. Now that I've isolated my variable, my solution set is b is less than or equal to 6. So if I look at the answer choices here, the correct answer is this second option. So remember, with this type of problem, you always want to see if the coefficient's negative, and if the coefficient's negative, you want to flip the inequality symbol. All right, so number 3 says, which statement best describes the following inequality? So we're back to translating. So I like to look at the problem and see if I can identify any operations. I see division here, I see subtraction here. This is a greater than symbol, and 20. So I'm going to eliminate the first one because it says 4 more, and that would be addition, and there is no addition. So I'm going to eliminate that. This next one says 4 less than the quotient of a number n3 is greater than 20. So this one's correct. Again, the reason why this one's correct is because if I box the than, and if I circle the is greater than 20, I do have is greater than 20. The part after than comes first. Quotient means division. A number here is x. So we're taking x, we're dividing it by 3. Second would be the 4 less. And then is greater than 20 goes at the end. So the second option there. All right, so now we're on number 4. Again, another translating. And I'm trying to determine which of these options matches this. So now I've got 2 and x touching, so that's multiplication. I've got +5, and I've got greater than or equal to 14. So I need to find a statement that has multiplication, addition, and the greater than or equal to 14. So if I look at the first option, twice a number plus 5 is at least 14. This one does work. So the correct answer is this first option. So at least 14, remember that means 14 or more, so greater than or equal to. Twice a number means multiplication, that's right there, plus 5. So the reason, for example, why the second option doesn't work is because it says twice a number added by 5. So far that's correct. But is it most 14 means that it would be less than or equal to 14 because it can't be any more than 14. So that option's out. All right. Number 5, true or false? 5 is a value for x that will make the following inequality true. So we need to see if I replace x with 5, if that would make the following inequality true. So there's several ways that you could do this. You could solve this inequality and plug 5 into the solution set, or you could plug 5 into the current inequality and see if it works. Okay, so the first method, solving the inequality. I could set this over 1 and cross multiply to get rid of the fraction. And so 1 times x minus 8, anything times 1 gives me the same because of the identity property. So x minus 8 is by itself. And now I have to cross multiply the next two terms. So 3 times negative 1 is negative 3. So now I've gotten rid of the fraction. I can drop my bar, and I'm trying to isolate x. So I'm going to add 8 to each side to get x by itself. So x, I found out now, must be greater than 5. This question is saying true or false. 5 is a value for x that will make the following inequality true. So this question is saying, is 5 greater than 5? No, it is not. So this statement is false. So that's one method that you could do this. You could also plug in 5 here for x, subtract 8, and divide by 3 to see if you get a value greater than negative 1. PEMDAS says to do 5 minus 8 first, which is negative 3, then divide by 3 to see if you get a number greater than negative 1. Well, negative 3 divided by 3 is negative 1, therefore negative 1 is not greater than negative 1. So whether you choose the substitution method or the solving method, they both show that 5 is not a solution to the inequality. Okay, so the next problem, number 6, is a word problem. So this is where you really want to read the problem, highlight keywords, just like you can do in Horizon. To ride the Ferris wheel at the carnival, your total weight of the car on the Ferris wheel must be at least 100 pounds. Jenny and Michael want to ride the Ferris wheel together. If Jenny weighs 70 pounds, which inequality shows how many pounds Michael must weigh for them to be able to ride the Ferris wheel? So you want your weight to be at least 100 pounds. So at least 100 pounds means 100 pounds or more. So I'm going to start with that. Well, Michael and Jenny, they want to ride the ride together. Jenny, she already weighs 70 pounds, so we know her weight. We don't know Michael's weight, so we're going to make him X. But we know that together, Michael and Jenny, 70 plus X, have to be at least 100 pounds. Okay, so if I look at these options, I don't see my answer because the inequality is on the other side. So if I move the 100 here to the left side, then I'm going to have to switch the symbol. So if I do that, I get 100 must be less than or equal to 70 plus X, which is Jenny's weight plus Michael's weight. So if I look at my options here, the correct option here is the last option. Okay. The next question, number 7, says, which sentence is represented by 4x minus 5 is greater than negative 21? Again, this is a translating question, and if I look at the problem, I've got multiplication, I've got subtraction, and I've got a greater symbol. So I need to find a statement that has multiplication, subtraction, and a greater symbol. So if I look at the first option, the product of 4 and a number, that works so far, decreased minus 5 is greater than negative 21. So the first option works. Again, why does the first option work? Because product means multiplication. So the product of 4 and a number, 4x, decreased minus by 5 is greater than negative 21. Let's look at why one of these other options don't work. The second option says the difference of 5 and a number multiplied by 4 is greater than or equal to negative 21. One of the reasons why this doesn't work is because of the greater than or equal to negative 21. We don't have the or equal to. Another reason this doesn't work is because it says the difference of 5, so 5 minus a number multiplied by 4. So that would be 5 minus 4x. Okay? All right, so for number 8, it says the value v equals -2 and v equals -3 is a solution to the following inequality, true or false. So for this statement to be true, both of these must work. So if one of them does not work, then it's not true. Now, number 8 is one of those problems, again, where you could solve or you could substitute. I'm going to choose to solve this one. So I've got a two-step inequality. I notice that the coefficient is not negative, so I don't need to flip. I can go straight into solving by using inverse operations. So the goal is to get 6v by itself. So I'm going to get rid of the constant, which is -3, by adding 3 to each side. That leaves me with 6v is less than or equal to -12. I still want to get v by itself, and there's a 6 coefficient, so I'm going to divide each side by 6, and I get v is less than or equal to -2. If I go back to the statement, it says the value v equals -2 and v equals -3 is a solution to the following inequality. Well, let's first look at -2. Is -2 less than or equal to -2? Yes, it is. So that works. Is -3 less than or equal to -2? Yes, it's less than. So this one's the same, and this one is less than. So they both work, so it's true. Again, for number 8, you can use the same method mentioned before, where you plug each of them into the inequality using substitution and PEMDAS and see if they work. Okay, moving on to number 9. Which is the correct graph? Again, I'm underlining keywords, another strategy, for -2x plus 8 is greater than 12. So before I can figure out the correct graph that matches this, I need to solve the inequality. I need to solve the inequality and find the solution set. What I noticed here is I have a negative coefficient. Remember, the coefficient is the number in front of the variable. So because I have a negative coefficient, I'm going to need to flip the direction of the inequality. So I like to do that at the beginning. Some people do it at the end. I'm not sure what your teacher has shown you, but I know that in my classes we do it at the beginning so that we don't forget to do it. So you drop the bar. You want to get x by itself. So you're going to subtract 8 on each side. So now 12 minus 8 is 4. Bring down the less than, bring down the -2x. We still want to isolate x, so it's -2 times x. So we're going to do the opposite of multiplication, which is divide each side by -2. So x is by itself, less than is the inequality symbol, and 4 divided by -2 is -2. So x must be less than -2. So the less than symbol means that I need an open circle. So I'm going to slash the trash. C and D are out because of the closed circle. And less than -2 means to choose all values smaller than -2. So that means it's going to be option B. Option A does not work because all of these values shaded are greater than -2. Someone who may have picked option A may have forgotten to flip because of the negative coefficient. So B is the answer. I'm going to mark that down here, and I'm going to move on to number 10. Number 10 is another word problem. The Irving Student Council needs to, so hold on while I get my highlighter. Okay, the Irving Student Council needs to raise at least $300 for the school dance. If they sell tickets for $5 each, how many tickets do they need to sell to make enough money for the dance? So let's start with the at least 300. At least 300, again, is 300 or more. That's something you definitely want to remember for the test. So 300 or more. So if the tickets are $5 each, that keyword each signals that we are using multiplication. So $5 per ticket. We don't know how many tickets they're going to sell. We're trying to figure that out so that they can make at least 300. So 300 or more. So the correct answer is this last option here. Okay, moving on to number 11. the value x equals 8 is a solution to the following inequality. For this problem, I'm going to use the substitution method so that you can see whether or not this is true or false. A lot of people see that there's a negative here, but then they forget about it. So I'm going to put that negative with the denominator so I don't forget about it. They're telling me that x equals 8. So I'm going to replace x with 8. I'm going to follow PEMDAS. So that means that I'm going to multiply negative 1/4 by 8 because multiplication comes first according to PEMDAS. I'm going to add 2, and I'm going to see if that value is less than negative 3. So I'm going to do this part first. I'm going to set 8 over 1, and I'm going to multiply the factors that are across from each other. So 1 times 8 is 8. Negative 4 times 1 is negative 4. I'm going to finish this out by dividing. 8 divided by negative 4 is negative 2. And I'm going to do negative 2 plus 2, which is my second step, addition. And that gives me 0. 0, I'm asking myself, is that less than negative 3? And that is false. 0 is actually greater than negative 3 because it's closer to 0. So I choose false. And you can think about that in terms of a number line. Okay? All right, so now we're on number 12. Okay, so number 12 says, which of the following shows the solution to the inequality below? A lot of people are intimidated by a question like this because of the fractions. So what we've talked about in class is that we can change the fractions to decimals by using our calculator or our knowledge of equivalencies. Because this is a negative coefficient, the first thing I'm going to do is I'm going to flip the direction of the inequality. And then the second thing I'm going to do is I'm going to make these consistent. So I'm going to change negative 15 and 1/2 to negative 15.5 because I know that 1/2 is the same as 0.5. So this is just a one-step inequality, so I need to do one thing to get x by itself. So I'm going to divide each side by negative 2.5. And I'm going to get x is less than or equal to, you're going to need to use your calculator. So again, I'm going to do 15.5 negative in the calculator, and I'm going to divide that by 2.5 negative in the calculator, and I'm going to get 6.2. So x is less than or equal to 6.2. Again, I switch the direction of the inequality symbol because the coefficient is negative. So the first option is correct. Okay, so we're almost finished here, just a couple more. I know this is a long review. Hang in there with me. Number 13 is another word problem. So I am going to highlight keywords. Miss Kim has at most $22.50 to spend at the carnival. She bought a hot dog and a drink for a total of $3.75. She wants to spend the rest of the money on ride tickets, which cost $1.25 each. Which inequality describes the number of rides she can buy? So let's first start with our inequality statement. She has at most $22.50. That means that she can spend exactly $22.50 or less. She doesn't have any more money than that. So that's going to be the less than or equal to symbol. Miss Kim was hungry, so she already bought a hot dog and a drink for $3.75. So we have to take that into account for the money that she already has, into the $22.50. But she wants to use the rest of the money on rides, and the rides cost $1.25 each. Again, that multiplication keyword. So the cost of her hot dog and drink is $3.75, plus she wants to spend $1.25 per ride. We need to figure out how many rides she can go on so that she spends no more than $22.50. So the inequality that matches this is the second one. So if we went to go solve this inequality, we know that we would have to take off the cost here of the hot dog and the drink, and then we know that we would have to divide the remainder by 1.25x to see how many rides that she can go on. We are not asked to solve here though, we are translating. Okay, number 14, the infamous select all that apply. Again, highlight keywords. select all that apply. Which values below make the inequality true? For this problem, there are several numbers here that I need to see if they work for this inequality. So this is not a problem where I want to use the substitution method. So instead, I'm going to solve this inequality. First thing I'm going to do is I am going to change 4/5 to 0.8. I have that memorized. If you don't know that 0.8 is the equivalent decimal for 4/5, then in your calculator, you can do 4 divided by 5 to get that value. Okay, so I have a one-step inequality and there is no negative coefficient. So I'm going to go straight to inverse operations. So I'm going to subtract 0.8 and then 10 minus 0.8 is 9.2 is greater than x. Now, if you can't do that in your head, again, you can use a calculator. A lot of students don't like the fact that the variable is on the right side. So if you want to move the variable on the left side, you may, but remember, if you move the variable on the left side, you have to switch the direction of the inequality. So this statement can also read x is less than 9.2. So now I need to pick all of the values here that are less than 9.2. Okay, sorry about that. So we need to pick all the values that are less than 9.2 because this is a select all question. So we're not going to pick 9.2 because it's not less than 9.2. We're not going to pick 10 because it's not less than 9.2. However, we can pick 9 because it's smaller than 9.2. We can pick 7 because it's smaller than 9.2. We are not going to pick 11 because it's not smaller than 9.2. And lastly, we are not going to pick 9.3 because it's not smaller than 9.2. So for this problem, we are going to pick 9 and 7. All right. So the next question, and I believe, yes, the last question is number 15. Which answer below shows all solutions to the following inequality? So this question is asking us to solve. Again, we've got a lot of decimals and fractions, but we should not be intimidated by those. So since these two are already decimals, I'm going to go ahead and make the 3/4 also a decimal. So I'm going to make that 0.75x. Again, if you do not have that memorized, you can take your calculator and do 3 divided by 4. I'm going to copy down the 1.5. I'm going to copy down the greater than symbol, and I'm going to copy down the 10.5. I do not need to flip the direction of the inequality in this problem because the coefficient is not negative. So I'm going to drop the bar to show that whatever I do to the one side, I'm going to do to the other. My goal is to get x by itself, so I'm going to add 1.5. And that's going to give me 12 is greater than 0.75x. And then my second step is going to be to divide each side by 0.75. Again, you might not be able to do this in your head, so you're going to use your calculator. 12 divided by 0.75, and you're going to get 16. So the solution set is x must be greater than 16, which is the second option here. All right, guys, so that's our test review. Remember, if you still don't understand something, you can go back, rewind, play it again. But hopefully you're feeling a little bit better now about inequalities and you are ready for the test. Good luck. Talk to you later.